operational. But I mean, I think that's a level of detail that we can get into for the next rev because we have bigger first order questions to get into that. But you're right. I mean, I think it's inevitable. You have some difference.
At the interim, maybe we should invite for the question more about more operational.
Yeah. And
But
maybe
that's up to you how to
I would say we just sort of hunt the question just sort of, so let's focus on these big ones. That's we'll have to figure that out.
Good morning, all. I was just waiting for some of the presenters to finish their last minute conversations. So it's Friday morning and we've been here a long time. So welcome to DPRIVE, DNS Privacy. I'm Tim. Benno's filling in for Brian. Brian's on the other side of the world. So if there's any mistakes, we can throw him under a bus unless that's poor form. So, and our very responsible area director, Eric, they're in the front row. So Paul Hopkins offered to do minutes, so thank you. We'd need a Jabber scribe because we all fail at doing Jabber. So if anybody can manage to make that work, that would be super great. I know there's a bunch of people at Meet Echo as well. You all know the note well. You should know it by now. We should be able to sort of repeat it by heart because it is Friday morning. So just keep that in mind. Oh, you can do the Jabber relay? Gold star. Thank you. Blue sheets, they're going around. So please fill them in. We'll collect them later. We've got a short agenda. Mostly it's stuff that's coming in. So 3 documents updates. The BCP, of course, has been finished and we submitted it. Done the Shepherd write-up and it's now in our very responsible AD's hands. The 7626 biz has been done. And that actually looks like, I think it's moving forward pretty quickly. And then we adopted the X over TLS draft. And so that one's in our queue. So that's pretty much the only current one that's actually in our queue. But we've got lots of other stuff that's sort of floating around. And of course, since most of you are at the pretty excellent ABCD BOF earlier this week, there's always good times there. So some stuff will probably end up floating this way. And some of those documents are going to be on the menu today. The adaptive DNS privacy, which Tommy just had in the BOF, and then also the Oblivious DOH draft. I don't think you guys mentioned that. And then the DPRIVE privacy policy. That looks like there's a double type in there. So those are the big 3 drafts. And then the big one is actually the phase 2 requirements document that we had the interim on. Alex, Jason, who I didn't think was going to be here, and Benno are going to do that. We're trying to prioritize some of those requirements. We're not trying to solve everything here today. That we're just going to go down in rat holes for that. And our plan is to adopt that as a working group document only. So it will be adopted, but it's mostly for us to work on and to sort of help sort all those requirements out. And so that's essentially our agenda today. So there's basically the 3 drafts and then the big discussion about the requirements. And that's going to be a pretty free-flowing conversation. So I think what we'll do is that's it. So Tommy, where are you, sir? You're first. Actually, you've got both. So you could do one and then the other?
Yeah, so Chris will actually do the second.
Okay. It was unclear, so I apologize for that.
No, thank you.
Okay. Thank you.
All right. Can we go full screen?
Oh, yeah. All right.
Okay. All right. Good morning, everyone. Happy Friday. You've made it this far. So I'm Tommy Pauly from Apple. I'll be presenting this document that I've worked on with Chris Wood, Eric on our team, as well as Patrick McManus. And so this was presented in the ABCD BOF. The main focus I tried to have there was on the way that we do discovery, how we're trying to approach the problems, and particularly how we interact with the local networks, because that's very much the focus of that BOF. For this, I'm going to cover a bit of that, but I also want to talk about some of the mechanisms that we're trying to do at a bit more technical layer. So it'd be great to have everyone's input here. We did, these drafts are marked as being under DPRIVE because it seems like they fit under the category of DNS privacy. However, I think there's still discussion about where exactly this work should progress. All right, so of course, some background to start with. Here's our picture of our status Quo DNS. We have 3 parties generally involved when we're not doing any other privacy mechanisms. We have our client, we have our local network resolver that we're assigned via DHCP or RAs, and we have the actual names and origin servers we're trying to reach. So we see this common trend right now of looking at how do we use these private trusted resolvers. Oftentimes these are public recursive DOH servers, and it often ends up skipping entirely the local resolution infrastructure. And this has some concerns, certainly for people who are running that local infrastructure, but also as an operating system vendor, it does have concerns that are raised about how are we dealing with names that do need local breakout on an enterprise network or have some local information. And I think we need more of a kind of split DNS model when we're thinking about these things, because we do need to trust the things that are authoritative for the right resources. So the goals that we have in this document, which we're calling Adaptive DNS Privacy, and this is kind of the overall architecture document. The other one that Chris is presenting is more of a detailed technical bit for how we add some extra privacy on top using Oblivious queries. But the goals here are to overall improve our DNS privacy for client requests without requiring that we have some fixed or whitelisted list of public resolvers that we're doing and skipping all the local infrastructure. And so in order to get to this type of decentralized architecture, we think that we need to discover many different encrypted DNS servers, and we need to have clear indications of when to use them. And there's a basic premise here that there are scenarios in which we don't necessarily want to send all of our queries through the local resolver. And I think these represent a lot of scenarios in which I may be on a network that I don't totally trust, and I don't think it's appropriate for it to see all the names that I'm accessing and be able to build up a profile about the user. We also want to define how the clients can make sure that they're interacting correctly with enterprise names that are, private names that are only going to resolve here, and we're not leaking them to other places, that we work correctly with content that is indeed owned by the local network and cached very locally and can be optimized that way, as well as any local policy that has to do with filtering rules that the provider may have. And then the last part is that we want to provide a mechanism for when we really don't trust the network that we're on, or we want to have an extra privacy mode, a way to make Oblivious queries such that we don't even have to worry about, is this public resolver that I'm talking to something that I really can trust to not log what I'm doing, to make sure that even it cannot see everything I'm doing and build up a profile about me. So that's the scope of this document. So specifically, I think one of the interesting parts technically is how do we discover the encrypted resolvers that are appropriate to use for different names? And there are many different options that you can have here. You can have whitelisting, you could have information that comes over DHCP or RAs. But what we are proposing in this document is to have the information about what I should use to do my encrypted resolution come from the DNS itself. Because that's kind of the system that we're working in, and it seems to make most sense. So this proposal is using the service binding records. The names are still in flux. Currently, they're called SVCB and HTTPS service. These are records that are able to communicate, amongst other things, alt-serve and ESNI keys, but we also want to use them to indicate the information about what DOH servers are being designated for a given zone, essentially. And we also want to make sure that these designations are things that we can validate and trust such that people can't intercept it. So we do want to use DNSSEC to sign these records particularly, and that's a very important part. So a lot of people have also brought up questions about DNSSEC. We'll get into that a little bit later. So the picture ends up looking, if we just add one more step, something like this. We do have our local resolver. We definitely will use it. But let's say I then discover that there is a designated DOH server for the zone under example.com. So for any names within that zone that may be private or sensitive, I know that it's safe to use that DOH server. And I also have a pretty good chance that this DOH server is something that maybe I could use for better coalescing, because this is actually something that is being managed by the same entity that is managing the main example.com server. So as a difference from just using a public recursive, it's kind of still more a three-party system. We haven't added that fourth party into this. And then, of course, this thing could expand to be much bigger, because we actually have many different designated servers. We also need to make sure that these things play well with VPNs, etc. So one of the pieces of complexity that this does add is that clients, in this case, do need to be aware of the right rules for when to use what. As someone who implements our VPN split DNS logic, this is something that we definitely have the ability to do today. And so one of the questions is how this scales beyond that. So getting to the details of how the records are communicating the DOH information. So the service binding record is a new RR type that we would be querying alongside our A and Quad A records. And it can encode the service information, such as any alt service information saying that, oh, by the way, I support Quick. It will also give us the keying material that we can use for encrypted SNI. And in this document, we are adding two more things to the registry of what is defined for the key value pairs here, to include the URI template for a DOH server that is designated for this zone, as well as a encryption key if we want to be able to bootstrap doing oblivious queries to this same server. And I do want to point out that a lot of the benefit of this is related to when we do have ESNI keys. So today, oftentimes if we're doing DOH to some server, yes, we are encrypting that name, and maybe that is private from a local network, but it is pretty trivially easy, and people are already doing this, to look at the SNI that is going through the TLS handshake. And if they're not using TLS, they're even more obvious about what they're accessing. So it is a requirement to really get a fully private name solution that the server infrastructure of who owns this name does need to change. They need to add an ESNI key. And so essentially we're saying at the same time, give us the information that helps us bootstrap the encrypted DNS as well. Hello. So the details of the formatting, these are two different examples of how you can encode this. The service binding record has an aliased form and a non-aliased form. These are just two ways that that can play out. It's relatively simple. All right, so some common questions I just want to address and have some discussion about, or your thoughts on. So one is, why are we using DOH and not DOT? We'll get into that. Why are we using DNSSEC? Some people are allergic to DNSSEC and some people love it. So that's an interesting conversation to have. And then also, how does this overall system get bootstrapped? Because it seems that you need to do a query over some resolver that you may not trust in order to find out who you do trust. So let's go through each of those three now. All right, so first, the choice of protocol. Right now, we are focusing on DOH. Some of the discussion, if you may have seen on the ADD list, has been questioning why people want to do DOH. And some of the reasons that have been brought up indicate that maybe it's so it can hide, and it'll be easier to get through various firewalls and other things. For us, that is not really the reason that we're looking at this. There are other benefits we see in DOH that work well in this architecture. So one, it does allow the possibility of connection reuse with HTTP. So like if I end up doing a DOH connection to example.com, I can potentially start doing more requests to that same server if it happens to be co-located. I think one of the biggest ones for me is that it allows us to migrate to Quick very easily. Of course, we can define a DNS over quick mapping. I think there are various proposals for how to do that. But this allows us to fairly trivially, in both a client and server implementation, move from HTTP 2 to HTTP 3. And that just requires updating the libraries underneath, and we don't really need to change any of the formatting. And another big one is that the HTTP header format does allow us more extensibility and allows us to do things like what we're doing for Oblivious queries, to be able to have different forms of encapsulation, as well as to be able to proxy queries around when we want to do obfuscation of what IP address we're coming from. You could, of course, add these things to protocols like DOT, but the format for that is simple enough that it was a little bit too much work to extend. All that to say, though, this system for saying how we want to designate encrypted DNS servers could equally work well for saying that here is a DOT server that we should use for this. All right, so another key thing that we want to do is make sure that the designation of a server is signed, that we are sure that this is not some rogue record that we have saying, oh, send all of your queries for google.com to some evil server. Like, that would be a pretty bad attack and end up really harming privacy. So if the DOH server designations are not signed, they can be steered around. What we currently have in the document is the requirement that these designations are DNSSEC signed, because this provides a mechanism to tie this designation to the person who signs the zone. And this is a good root of trust for the information about what we're getting from DNS. It also allows us to have a fairly public record that you could follow and easily corroborate from other vantage points. One of the concerns here is that it does seem like certain deployments find it a barrier to entry. There are a lot of large deployments that are not necessarily signing all of their zones. So if people do have thoughts about ways to make this easy to do, or some people have talked about, oh, can we have other signing mechanisms here? That would be good to look at. Although I do want to emphasize that we probably shouldn't be reinventing something that's just another DNSSEC, because we have a solution already here. And lastly, talking about the bootstrapping, there's a couple different models that we can use here. So one thing you can imagine is that a client can know a set of names initially that it does expect designations for. So for example, on, I think, both Android and iOS devices today, when we join a Wi-Fi network, we try to do some probes or captive portals, and there's some initial traffic. So along with that initial traffic, we could easily imagine that there would be some generic non-user identifying queries that go out that help us discover the designations for kind of the system default traffic. So on an iOS device, we're probably going to be connecting back for push notifications to Apple servers. And so that's an opportunity to do a non-user specific query that allows us to discover some designated DOH server. So we will have queries, of course, that go always over the local DNS infrastructure. And then after that point, depending on the stance we have towards that local network, we have a couple different options. So if this is a network that maybe is my carrier or ISP that if the user has an explicit relationship with and that they do trust, we can imagine that some of this designated DOH is really done at a kind of like a best effort basis, right? Like when we know that we do have some designations, we make those private. Those correspond to servers that have ESNI keys, and we do it that way. If we are a bit more paranoid and we don't trust this network, I'm at some sketchy cafe when I'm on vacation, I don't know what's going on, we could instead use Oblivious DOH, which we'll talk about a bit later, and that as long as we have knowledge of some DOH server that's out there that allows this, as well as some way to proxy to it, we can start querying for more names without giving up both our IP address and our query content to that DOH server. So as a little workflow through here, let's say I get on a network and example.com is my default thing that the system does. So it will do a query to the local recursive for the service binding records for example.com. It will then find out with a DNSSEC signed record that there's a designation to dns.example.net, and it will know where that DOH server is. At that point, we've essentially bootstrapped our DOH connections. We then ask it for any names within that. Maybe these are private names that may be sensitive for some reason, and then we can have connectivity there. So the local network can certainly know that, yes, you're talking to this general entity. You're talking maybe to this CDN or to this general provider, but you don't know the specific content that they're asking for within that. There's also information that we can get from the DOH server itself. We're taking some phrases that we have from the int area and myth working groups of provisioning domains, because in some ways these are almost like virtual interfaces that we have that represent our relationship with various CDNs. And so these are new provisioning domains. So when we talk to a DOH server, we can also ask it off of a specific content type for some JSON description about what are the things that are provided here, so we can learn some of the other default names within this. So if I talk to Apple, maybe it says, oh yeah, I host iTunes, I host iCloud, and these are other things that you can get here. And then the client would request the same records to prove that designation and validate that there is a DNSSEC signature that says that this server is also authoritative for those. And there's some nice things you can do with DOH here, because HTTP2 can start pushing some of these default records to prove its designations for more of the different zones without actually wasting a round trip. So those are some of the answers to the basic questions that often come up. We have a couple different issues that we are working on, and we are having various conversations with people about. We need to make sure that we have a good story around multi-CDN deployments when you have names that are being managed by multiple different entities. We do want a good story about what we should do and what the recommendations are for zones that maybe aren't DNSSEC ready yet. There may be an option here, there may not be. If people have ideas, I'd love to hear them. We also want to have guidance on when it's appropriate to reuse HTTP connections that were used for DOH and start using them for other connections in a way that's not going to abuse privacy. And we also want to dig into more about the failure options, about how you fall back between these different server configurations. So at the bottom there is the GitHub link to where we have these documents. We have a bunch of issues and pull requests filed by people, and I encourage you, if you have thoughts, to chime in there, because that's a great way to interact with the authors. All right, I think that's my last slide. Chris will talk a little bit more about our Oblivious DOH in a bit, but if there are questions now, comments, that'd be great to hear.
Oh, I had some before people start.
Sorry.
It's okay, because this was discussed at the BOF on Tuesday.
Yes.
And it had a lot of people who had read it and had comments.
Yep.
It weren't on the DPRIVE list, so I figured they're all on the ADD list, which I read for a while, and then it got locked, and then I stopped reading it. So
yes,
I better go back and read
so we posted this to both
Yep.
lists. I mean, we posted primarily to
Yep.
DPRIVE and then also cross-posted
Yep.
there. Yeah.
Exactly. Okay, just wanted to double check on that.
That's
My co-chair was confirming. So we'll go to Ralph and cut the line at Ralph at the end there. So go, Mr. Brian.
Brian Dixon, GoDaddy.
Hi.
As far as the DNSSEC signing of zones, I'm not sure if everyone's aware, but GoDaddy is intending to make DNSSEC signing available to all of its customers.
Fantastic.
Don't have a hard timeline, but that'll be 40% of the internet.
That's great. I love that.
Alex Mayo for Nick.at. I think that is a pretty broad impact on the some of the general concepts of the DNS, because essentially you can like designate a server to be sort of authoritative for a domain, even if it's not authoritative according to the delegation. And you also like get into a gray area between this is authoritative and this is recursive, because the server could like provide other responses. So it's a completely new world of how DNS works essentially. So I think we should treat that pretty carefully. Yeah.
Yep. Yep.
The second one is, I understand that you defined a new resource record type.
That's
And-
defined outside of these documents.
Well, yeah,
Yes.
yeah. And have you looked at the other options that would be there, like the URI, RR type, and the Naptor records? Yeah, long time ago.
Right. So I'm
Especially
aware of the URI
looks
one.
interesting.
Yeah.
You could define a URI scheme that actually encodes all that information, and then But it depends
Right.
on where you actually want the new stuff to go. So it's
Yes.
like moving around bits from
Yes.
A to B.
That's true. So for the URI one, since technically the URI of a DOH server is under the HTTPS scheme, it seems like it may be a bit vague what the URI is if it is simply a HTTPS URI attached to a name.
The problem is you probably can't do the other things as query parameters to the HTTPS URI. So that's a little bit, but yeah.
Okay, that's a good point though.
And the other issue is maybe the broader one that
Yes. The
will for sure trigger some interesting discussions once.
absolutely. And I think as we've been talking to kind of various deployments, I think, there are cases in which this is just putting a DOH server in front of the authoritative. And that seems to be maybe one of the clearer reductions of this. And then people who want to do, I think the question is, do we want people to designate full recursives if they have them already? Essentially, like if Cloudflare has its large DOH server, is it most convenient for it to just say, yeah, just do DOH to our main recursive server, even for names that are hosted within Cloudflare?
Yeah, it appears to me a little bit as the hosts TXT of the 21st century.
Yep.
From the Jabber room, Peter Spacek says, I'm against adoption in its current form. Basically, this is a combination of custom-made Tor network limited to DNS plus auto-configuration magic on top. At the same time, latest research in privacy field has shown that hiding only DNS traffic does not actually help much because just the set of server IP addresses the client is connecting to is sufficient to reveal what website the client is accessing. For this reason, this humongous complexity is not justified. He then posts the reference in the research article, which is, what can you learn from an IP? Authors Simran Patil and Nikita Borisov. The link is in the Jabber.
Great, thank you. Yes, so to respond to that point, absolutely agree that the IP address alone does, in a lot of cases, give away a lot. This is trying to make it possible for us to have good DNS name encryption. As I mentioned before, it also does require that you do have encrypted SNI. And beyond that, it requires that whoever is hosting these IP addresses has a sufficient anonymity set of the name to address mappings. So essentially, it is possible to build a deployment, of course, that will not have good privacy properties. What we're trying to do here is make it possible, if you do have a deployment, to have good privacy properties if you deploy it the right way.
Hi, Stephen Farrell. So I'll comment on two questions, which are kind of really one question. I kind of generally like it. I think you're a bit optimistic about the NSSEC, but
Yep.
okay.
Me too.
Can you go to the slide with the bit of JSON there? So about these names here, the DNS zones you name here, and about the Oblivious feature.
Yep.
It's really not clear to me how a client is going to react differently to those versus things that are, how would it decide to use the Oblivious feature? How would it decide to treat names below foobar.net differently as it's trying to resolve stuff? I mean, how would a client decide that? Are you intending that would be a standard behavior that we would specify? Or
Yeah, and so that is, at least right now, kind of specified in there. I think the idea is, if I can have a provable designation from foobar.net to example.com.
But provable, you mean asserted? You mean asserted?
Asserted and signed.
Right,
essentially, that we have,
yes. I can sign whatever I want, right?
that the foobar.net
Not even
root,
signatures here, right?
so that the zone foobar.net signs
Right,
that.
but so in my campus company, tolerantnetworks.com, I could say I'm Apple. I can sign that, right?
You could say that you
have a relationship with this DOH server infrastructure that you would like them to handle your resolution.
Yeah. Okay. So the handling of that and how it doesn't lead to issues and how, what client behavior is part of the specification is unclear to me. And I kind of think it might be a bit wrinkly.
Okay.
So
Sounds good.
Yeah, Lorenzo Colletti, similar concerns to this. I mean, I think one thing with this specifically is, how does the client know that the DOH server actually has any sort of relationship with example.com, right? So it sounds like this information is actually duplicating the information in the HTTPS service record that tells you, I am the DOH server for this domain.
So okay, to clarify, and sorry if I didn't make that as clear when I was speaking through this, but it is in the document. This is essentially a hint of things that you should go look up using the HTTP service record to get that official designation.
Why not just use this HTTP service records with the TTLs? So then I get all the information that I need as a client.
Well, I think that the client, if it doesn't know about, so Apple.com, if it doesn't know that iCloud is a thing that it should ask about, this is essentially just a way to optimize and prefetch the common names. But you still have to ask for them.
But if instead of just an optimization, it was actually, I'm going to optimize by giving you the information that you will need anyway. If you use any of these, then I think it would be simpler. But we could take that offline.
Sure. Just by giving you the records.
Because at the end of the day, if I get this, I'm like, sure, you think you're authoritative for example.com. That's just your opinion.
Oh, yeah, and then
right?
you say
so then I
prove
have
it.
to ask for an HTTPS service. Just give it to me there with the signature.
So I think
That's the bottom line.
right. So what would happen is they would be pushing those records at the same time. I think it's often that at least from a client DNS API, we don't bubble up record information that was unasked for.
Okay. Yeah. I was thinking, okay. I had some other questions.
Do
I think
you have a lot? Because
Just
you've got
one.
3 people and we're like 10 minutes behind schedule already.
So structurally, why tie Oblivious and opportunistic to the end-to-end model? It seems like two different things.
Yep. I think those
There
can be
didn't
decoupled.
seem to be any explanation in the draft. Why?
And I think that's something that we're discussing about decoupling.
Ben Schwartz. So there's a lot of details here. I think it's tempting to dive right into all of the details. So thanks for the detailed proposal. I think we should still be thinking a little bit more about architecture.
Yes.
It seems to me that some people have said this, that you're building a spectrum between recursive and authoritative here. I think that's a cool idea. I think that it would be worthwhile trying to harmonize this with the recursive to authoritative encryption proposals, because fundamentally what I think we have here, to me, it looks like a mode switching resolver, which is recursive when when transport encryption is available, and stub when transport encryption is not available.
Right. I think the lines were cut after.
Vivek on my end. To enhance a bit of this, I encourage you really to look in the other transport like dot and DNS over quick eventually. I mean, we don't need ENSI and I for dot, for instance. I mean, there's just some simplicity that is there. And if echoing what Ben said, if we really could make that similar to what we have in the regular recursive to authoritative, it would be probably better. Make it the same pretty much.
Get that. Thank you.
Sorry, the last person in the queue, the queue was closed.
Didn't say that.
Yeah, we said. Yeah.
Okay.
Sorry.
Well, first of all, this is a comment for you and for you and for other drafts that have more or less similar principles of spreading queries across multiple servers rather than using a single resolver. I think there should be an analysis of whether this is compatible actually in providing more privacy than it does, because I've seen several claims that we should spread out the queries to provide more privacy. And this is exactly the opposite of the privacy protection model, at least in Europe and in the countries that follow the same model, which is about data minimization, so about sending as less data as you can to as less places that you can. And so I don't know if this is actually ever could be compatible and properly usable in this kind of context. And I think that before claiming that this increases the privacy, there should be some proper study, privacy impact assessment, deciding whether actually spreading data around provides more privacy than less. And also, it seems other people have already said that you're basically trying to get rid of the recursion in the middle and using the authorities directly from the client. I don't see how this would benefit privacy, because in the end, you're actually having third parties tell where the user's data should go. And again, this is not how privacy works. Privacy is about the data, the people choosing where the data go, and having some of the big internet platforms telling my client where my data should go is not helping my privacy at all.
Okay, so I think the assertion I would make to that is, if I'm about to connect to google.com, google.com for sure knows who I am, at least from whatever stance I am, going through some proxy or VPN maybe, but I do for sure have a relationship with them. And so I think analysis is warranted, but doing resolution using that same infrastructure to google.com is not giving them any new information about who I am. I'm about to connect to that same address that they are giving me. And so the idea is, yes, let's not spread it to other servers that have nothing to do with this, but if we know we can get back to the server that is actually the responsible hosting party, then we are not expanding the set of data that we're giving to the network.
I think we need to discuss that.
Okay, thank you.
So thanks. One thing I would want to say real quick before Chris jumps in is, we know it's discussed in the BOF, and the chairs are going to sit down and sort of talk about these drafts and stuff.
Great.
This part of this does fall in the DPRIVE charter work, and because our charter is pretty tight, sort of, so Brian and I are going to sit down and talk with Ben and David as well as about this and see where this goes, sort of thing. But if so, that conversation probably should end up start moving over to DPRIVE out of the ADD list, just to sort of, so we have a better way of tracking some of that.
That sounds good. Thank you.
Okay, great. Thanks.
All right. Hello, everyone. My name is Chris Wood, and I'm going to talk about specifically the Oblivious part of this proposal. So thank you, Tommy, for sort of giving the big architectural overview. This is going to specifically focus on how we want to proxy Oblivious queries in the case where we don't trust our particular resolver to do resolution for us. So Oblivious DOH, much like Oblivious DNS, is designed to support proxy inquiries between clients and an untrusted resolver. Pretty simple in concept. We have a couple assumptions we're making about actually running this in practice. In particular, there's that the clients, in order to run Oblivious DOH, need to know the public key of what we call a target resolver, which will eventually actually do the resolution of the name that the clients are after. And it needs to know the public encryption key of that particular resolver. It also needs to know the address of a willing proxy. Willing is sort of important here. As far as assumptions about what we're making about this overall system, minimally we require that the targets and the proxies are not colluding. Otherwise, whatever you would get from keeping these two entities disjoint is completely falls apart. And the goal, much like Oblivious DNS, which I assume most people here are familiar with, is to make sure that an entity which gets the actual name to be resolved doesn't learn the IP address of the entity which issued the query. Modular traffic analysis and things like that. So we're focusing strictly on what we can do best with cryptography. Traffic analysis is certainly important and something we will kind of keep under advisement, but TBD, future work, et cetera, et cetera. So to actually look at what an Oblivious DOH message looks like, it's very similar to a DOH message right now, except that the body, instead of containing potentially a plain text DOH message or whatever, or DNS message, it just has an encryption of an Oblivious DNS query, the contents of which I will describe in a little bit. The path for the DOH message indicates the target to which the message should be sent. So in this particular example, we have the client sending an Oblivious query to the target.example.net target with a specific URL path, indicating the content type that this is an Oblivious DNS message with some other headers and other HTTP goop to make it all work. So this is the scenario we have. Client wants to resolve a particular name, foo.bar in this particular case, using the target DOH server, target.example.net, and the client has learned the public encryption key via one of the mechanisms described in the adaptive DNS draft, or via carrier pigeon, or by some provisioning mechanism, that's sort of out of the scope of this particular document. So what he does is quite simple, much like in the Oblivious DNS case. He basically takes that name, encrypts it alongside a randomly generated symmetric key, which is K in this particular case, packages that up as the Oblivious DNS message, sends it to the proxy, indicating the target.example.com, who will happily forward the message over to target.example.com using the target name that was identified in the message. Target then naturally decrypts using its public key to discover the name that the client wishes to resolve, does the resolution to identify an address, and encrypts that answer under the randomly generated symmetric key K, and then sends that back to the proxy, who then just happily forwards it onto the client. Very simple. And the client will use it. And so the idea, much like Oblivious DNS, is that by having this proxy effectively in between the client and the target, there is a separation between the entity which knows the name, which is the target in this particular case, and the entities which know the IP address of the client. Now, of course, like if they're colluding the proxy and the target, the proxy could just say, oh, by the way, here's the IP address of the target. So that's not great. So that's an assumption we sort of make in the system, and I'll get to that in just a little bit later. I'd also like to point out that the threat model that we're sort of considering here is an adversary which would potentially sit in multiple places in the network, in particular between the client and the proxy, as well as between the proxy and the target, which is why these connections are encrypted via TLS. If you were not concerned, for example, about an adversary sitting between the proxy and the target, it might not be necessary to use TLS at all, anywhere. The message is already encrypted. You could just have something like a simple TCP proxy forwarding messages on behalf of the client. But because we're trying to assume sort of a worst case scenario, we put TLS everywhere. And it's sort of just good hygiene to use TLS everywhere. So I also note that the adversary could be sitting to the right of the target as well, between the target and the upstream authoritative. I didn't draw that here, but that's sort of included in the threat model. Right. So there are, of course, some deployment concerns that one might have in considering whether or not to deploy Oblivious DOH. First one, is the public key encryption overhead of processing for each individual query too much? It seems not. Of course, says the client. But considering that, we're going towards a world in which we have ESNI. I guess ESNI is the motivating factor here. Every single new TLS connection most likely will require at least 2 public key operations to even get things going. So it doesn't seem like much more of a stretch to do another public key decryption. Again, caveat, I'm the client. I do not speak on behalf of the servers. So if the servers are, think this is terrible, please tell us. Potentially we could reuse connections or do something like that. But to make sure that each query was not linkable, we use public key encryption for each individual query so that there's no state across consecutive queries from clients. A second big one is what motivates an entity to proxy traffic. So currently in the draft, what we have specified, and this is something we're still in discussion with various folks, is that a client will only use a target, a designated target, if that target is willing to also behave as a proxy for other traffic. And the idea being that it's in the best interest of the target to offer this particular service because it can improve the performance of clients connecting to the services that it hosts. Absent that, all queries will be sent through an Oblivious proxy, and the client, the user experience will degrade. Of course, if there are willing Samaritans that are happily run proxies, that would be great. But right now, that's what we've currently specified. Other question is, how do we know for sure that the client, or how does the client know for sure that the target and the proxy are not the same entity? Of course, as I was saying earlier, it sort of makes everything kind of fall apart. And I think at the end of the day, there's really nothing like technically, mechanically that the clients can do to sort of, get that assurance. You can tweak with and play with the resolution algorithms and how you choose your proxies and your targets to sort of try to improve or decrease the chance that they are the same entity. You might, for example, choose like a proxy that's very close to you and a target that's very far away for some definition of far and some definition of distance. And maybe that has a good chance of them not being the same entity. But really, the clients don't really have any visibility as to whether or not there's a relationship between the proxy and the target. Much like clients don't have any knowledge of whether or not a TLS server is exfiltrating keys and just sending them off to someone to, decrypt traffic. So I think we kind of, for the most part, take that as a given. I guess the last question is why use DOH? Like why use DOH as the transport as a proxy? And I just want to go back to the earlier slide, this one about the threat model. Because we're assuming that the adversary can sit at multiple vantage points in the network, we want to encrypt that connection because it's Oblivious DOH. It just makes sense to use DOH, which has HTTPS, which has TLS. Now, like I said earlier, if you are assuming sort of a weaker adversary, one that's not proliferated throughout the network, perhaps a simple TCP proxy might suffice. But for now, we're sort of assuming the worst case, and we're using DOH. There are possible different directions you could take this. For example, if you wanted to build Tor, perhaps I shouldn't have said that, but if you wanted to do something like Tor, in which instead of having just a proxy that forwards an encryption along from the client, so instead of having a proxy that just forwards a message, and you wanted one that actively decrypts something from the client, discovers something else that could potentially be another encrypted message itself, or something to resolve and send it. You could in theory build that into the protocol, but it's not clear right now that that's the direction we want to go in. I guess another concern or observation that has been raised is that this is a bit too specific to DOH itself. You might want to generalize it to say just HTTP messages and make DOH a specific, or DNS a specific type of HTTP message that you might send and might be proxied from a client to a particular target. So what would that variant look like? Oblivious HTTP? Well, quite simple. You would just, instead of having an encrypted DNS message or inside the client request, you would have an encrypted HTTP message. And you would have the content type indicate that this is an oblivious message, and the proxy would forward it as such. I'm not advocating for right now, this is absolutely the direction we should go in. There are potential questions to be asked about whether or not this opens up or turns the DOH specific target into like or DOH specific proxy into an open proxy. But I think those are things we can sort of work through. And it'd be nice if this general mechanism was potentially used outside of DOH. So as Tommy mentioned earlier, we have a couple places where you can get more information about this particular work. We have the draft on GitHub. There are two sample projects that have reference code for both the Oblivious DOH functionality itself, as well as a server that you can spin up in Google Cloud if you wanted to. And so you can check them out. I encourage folks who are interested in the Oblivious DOH stuff to take a look at the draft, as well as to take a look at the Oblivious DNS stuff from which this work originally came, and either send us email or file issues on the draft. And with that, I will take any questions. 5 minutes, okay.
Paul Hoffman. This is the third Oblivious foo thing I've seen.
What was the first one?
Was Oblivious DNS in general.
Okay. Yeah.
Sorry, and I forget what the middle one was.
Paul, finish your question, but I want to close the line now.
Yeah,
okay.
Sure. Right. I mean, given that we're actually within
and we have
2
5 minutes.
Yeah. So I think you should do this as Oblivious HTTP, and I think you should not do it here. It is actually not appropriate for DPRIVE. I could totally see a working group getting spun up with other things like that, but this has so little to do with DNS and so much to do with Oblivious. take it somewhere else. But it certainly, then we would have that here, both for stub to recursive and such like that.
Yeah, thank you. That makes perfect sense. It's here because it has DOH in the name right now. But yes, if we happen to go down the Oblivious HTTP route, perhaps we would take it somewhere else. Yeah,
Ralph Backham, I'm a bit scared by the sort of network of open proxies that we are generating. I mean, DNS still has a imbalance when it comes to the query and the response. And I can easily see how you could abuse that to kind of kill a DOH server, a designated DOH server, by just kind of blasting absurd amounts of traffic to it from a kind of a small to medium botnet.
I'm not sure how the proxying makes that problem worse. Clients could also themselves send these encrypted
but they
things
can
directly
hide
to
them. I mean,
targets.
it's easier to identify if you if you don't go over the proxies, I guess.
Okay. Noted. Yes. Potentially there are some issues that we need to work through, but yes, we'll take that into consideration. Thank you.
Thiru, I was wondering why not use split VPN or other techniques to basically only tunnel DNS traffic? I mean, why do you have to reinvent the wheel with regard to this unique technique that you're coming up with?
Can you repeat the question? I'm sorry.
Yeah, I was just saying, why not use split VPN where you could tunnel just the DNS traffic and that would mask your IP address from the target DOH server? Why this technique? How is it better than split VPN or Tor or other services that are there already to anonymize the IP address of the endpoint?
Are you saying VPN to the target or VPN to something and then that's something?
Yeah.
That's another type of proxy.
Right.
There's no reason not to do that.
Correct. So I'm saying it would be good to discuss the pros and cons of each of these mechanisms to see.
I think there's a discussion, there's a section in the draft like describing what other proxy technologies could be used.
For example, I see Cloudflare hosting already a Tor service within the Tor network, right? Onion service. So how's that better than this one? Or that would be a good discussion to have.
Absolutely. Thank you.
From the Jabber room, Peter Spacek, limiting ourselves to DNS is not going to help privacy for reasons stated in the previous discussion. Let's try Oblivious HTTP transport.
Okay, thank you.
All right, Stephen Farrell. So I guess I'm in two minds about whether you should generalize this or not. So previously, I mean, it would be really nice to have a standard Tor-like thing, I think. But it's not clear that people will be willing to offer servers, and you don't get the kind of the agility that Tor requires itself to deal with to do circumvention if you standardize. And so technically, it might be nice to standardize to expand this to be a more generic thing. But then you might not get the relays offering service, and you might not get the circumvention you need. So it might actually be better to think about this as a purely DNS-oriented thing, because maybe in that case, you don't need the agility that you need for kind of more full circumvention, and perhaps people would be willing to offer relays. So I don't know. But either I think is a good thing to do, or maybe both.
Yeah, thank you. That's a very good point. I will note that if we don't do any generalization right now, if you have a colluding client and target, you can still use the proxy to like send things that are not DOH messages. You could just say like, oh, this looks like an Oblivious DOH message, and the proxy will happily move it, but actually it's something else. So yes, interesting questions to answer. Yes.
One quick sec. If any of it can move to the mailing list, just in the sort of a function of time, that would be great. But just try to keep it short because we're literally starting to run way behind schedule, sort of thing. Anyway, but go ahead.
So Mike Bishop, couple observations. One being that if your proxy is far from the client, then you will get poor CDN mapping. So your results may not be as good. Also some observations from the structure of Tor. Tor uses a consistent first node over a long period of time because under the theory that it is better for a small fraction of clients using that node to be compromised all the time than for all clients to be surveilled a certain percentage of the time. So you might consider using the same relay over a longer time scale.
Yeah, which proxy we use and how we actually sort of stripe the queries across proxies and targets is still something we're sort of working out. But yes, that's a very good point to raise.
And you might also taking a clue from Tor, you might want to enable the use of multiple relays.
Yes, it would be nice to sort of extend it in that direction as well.
Because that way you increase the group that would have to collude to get the whole chain.
Yes.
Lorenzo Calviti, just please bear in mind latency as well. I think, for example, the fact that that it uses post means you can't do zero RTT reconnect, and so the DNS does need to be latency sensitive. Also, bear in mind that DNS is extremely lightweight at the moment, and sort of a full TLS handshake can be for quick could be like 10K. So we sort of try to keep that cheap as well.
Yeah, I would imagine that the clients would have sort of persistent connections to the proxies, but still be doing the per query public key encryption. But yes, these are of course very good points to raise.
Brian Dixon, GoDaddy, have you thought about or looked at three-way party encryption for at least part of it, so you don't have to rely on the trust between the proxy and the target?
I'm not sure what you mean by three-way party encryption.
It's one of the Diffie-Hellman things you can do with 3 parties instead of 2.
Like group Diffie-Hellman?
We'll take it offline.
Yeah, that would be good. Okay, thank you.
Thanks. Good morning, everyone. I'm Thiru. I'll be presenting our draft on DNS server privacy policy with assertion token. Yeah, the agenda is to go over the problem statement and the solution view and the privacy policy of the DNS server. It's asserted by a token, and then the examples of some privacy assertion tokens. Why do you need DNS server privacy policy, right? What are the user needs, basically? One is that even with today, the user does not know what the DNS server's privacy policy is. He has to go and search and find out what the DNS server privacy policy is. And the other bigger problem is what happens if the DNS server privacy policy changes? The user would not even be aware that the DNS server privacy policy has changed. And the third one is, how do you know that what the DNS server is saying is actually the true statement of the DNS server privacy policy, right? And the fourth one is, because many of the networks do DNS filtering, how would the client know whether the DNS server is doing any sorts of DNS filtering? The solution is basically to let the user know what is the URL of the readable DNS server privacy policy, so that the user can go over it. The second part of it is to provide a machine parsable DNS server privacy policy that allows a DNS server that the client can pick which complies with the DNS client's privacy policy. We have aligned the attributes in the DNS privacy policy to be closely in line with the drop structure in the best common practices in DPRIVE. And this would require some user consent and minimal human intervention to select discovered DOH or DOT server. The other advantages of this mechanism would be that the client would notice any updates to the privacy policy changes, and the user would be notified if the privacy policy claims of the DNS server changes. And finally, the client can select a DNS server that meets the privacy preserving data policy requirements of the client. The solution proposal is we have a DNS server privacy policy. It's in JSON. It would be signed by the domain operating the DNS server. It has to be signed by the domain operating the DNS server, because the DNS transaction data could be used by various entities within the organization for analytics, for DNS filtering, anomaly detection, and other purposes. Typically, many of the typical DNS servers would be subjected to auditing by a third party for security and privacy. So an auditing company can also optionally sign the privacy policy statement. This is typically done today for VPN providers to go to third-party auditors, because they provide VPN services for IP anonymity. And this has to be signed probably by an OV or EV certificate for privacy claims from registered organizations. This would at least prevent malwares from hosting and getting a domain and getting a certificate for that domain. And the last part of it would be to determine what kind of DNS filtering would be done, whether the DNS server is doing malware blocking or has some policy which could be censorship or some blacklisting, organizational blacklisting rule it has to basically block certain domains. This is a huge list of attributes that we have listed in the draft. I mean, I'll go through some of them, whether the IP address is PA or not, logging of transaction data and its corresponding duration, whether the user identity is logged and the duration for that, and type of DNS filtering, malware, or any specific policy for blocking that. Many of the DNS providers today share the transaction data with partners and the name of the partners, and whether anonymous data or pseudo-anonymous data is shared with partners, and if any data is transferred to third parties. And typically DNS servers which do filtering log the DNS data which is being blocked for notifying users, and any logging for analytics like anomaly detection, and whether it does QNAME minimization and a human readable URL, privacy URL, and an audit URL. And if the client is communicating with an DNS forwarder, then it should also include the DNS recursive server's privacy policy, and if the connection between the DNS forwarder and the DNS recursive server are secure or not. So what are we doing to get the privacy session token? This is very similar to the work happening in several working groups like RAT, STIR, and other working groups where we're using PAT, which uses JSON Web Token and JSON Web Signatures. Client retrieves the privacy session token using one of the methods being discussed in the DNS of working group. The object has to be created by the domain hosting the DOH server, and optionally can also be attested by the third party which has done a privacy and security audit of the DOH server. So this is just a simple example of a PAT object. You have an authentication domain name, the time it was issued, the expiry time, and the privacy information blob, which includes all the privacy details for the client and the machine to parse. And this would have the JWS protected header, which would point to the signature algorithm and the certificate public key to use for signing the payload. And as you see in this example, we have this payload both protected by, signed by the operator who is operating the DNS server, as well as the third-party auditor. Any questions and comments?
Wow.
Well, about it.
Yeah.
I'll make it really short. I said this also on the list already, I think. This seems like a sort of reinvention of like EV certificates for DNS servers. There's a lot of policy from companies and auditors that are not technical. So specifying all of these technical things in the pretense that DNS clients can use that policy, even though they can't verify most of the policy, seems a bit weird to me.
Mark Nottingham, member of the now long defunct P3P working group. I would very much encourage you to explore deeply why that effort failed so badly, because this seems to have many of the same problems. Okay. Beyond that, I don't know that, requiring a new kind of consent to use the internet and for users to understand a new kind of consent model is the right thing to do. We already have a consent problem on the internet. We already have a lot of complexity, and layering in something new is I understand how in some jurisdictions it's the natural thing to lean towards, but it doesn't mean it's right for the entire internet.
Ben Schwartz. So I think there are several different layers here where we start with this idea of getting some blob of potentially essentially opaque information from the DNS server, a self-description of some kind, and then potentially that can be machine readable, and then potentially that can have signatures layered on top of it. So I think that I'm supportive of the idea of being able to get an essentially opaque, human readable set of information about a DNS server. I think that could be very useful and essentially usable. I think that the idea of stating it as a privacy policy already dips our toe into policy areas that are not really, in my view, not really our domain. I don't think that we are well equipped to specify that DNS to even distinguish between things that are and are not privacy policies. I don't know that the IETF could draw a line and say this block of text is a privacy policy and this block of text is not a privacy policy. So I wouldn't be able to say with any confidence about whether somebody had implemented this correctly. And then the machine readable formatting, I think, is not going to work. I think that the reason for that, from my perspective, is that lawyers are very particular about the precise words that they use in legally binding text, and trying to reduce that legal language, which uses the full scope of human expression, to a machine readable format, I think is, in my experience, not something that lawyers would be willing to do. For example, one of the things that comes to mind is you mention retention lifetimes here. Most policies describing a retention lifetime have various kinds of exceptions, explicit or implicit, for different investigating attacks on the system, for sometimes different kinds of law enforcement requests, maybe some kinds but not other kinds. I don't think this can be reduced to a fixed schema. Okay. So I think that the thing that I think is great here is I would love to be able to get, for example, a URL from my DNS server that says, this is a web page you can go to get more information about this server. Okay. And I think that actually addresses sort of the 90% use case that you're getting toward here, and avoids getting us stuck in a lot of mud.
Yeah, we are not avoiding the human readable created by lawyers. I mean, we still provide that, but I understand the concerns that you're raising with the machine possible. At least the one that was interesting was the DNS filtering one. For example, like today, Mozilla uses canary domains to block, so that would at least be coming as part of a secure communication channel. Right.
Vittorio Bertola. Personally, as a user, I would find this useful. And I think I would like to have both, so that the URL pointer to a properly lawyer-written statement, and as much as possible a few data which can be machine consumed and presented by my client in a useful way, but then it depends on clients whether they want to implement this. I think this will have to merge with any work we're going to do on the server discovery, so it would be interesting to have the format for the data, and then maybe we'll find other ways of
I mean, it has to coincide with a server discovery, and both the privacy URL and audit URL there are pointing to the human readable URL, so that's not going away.
Yeah, and the other point,
they are mandatory attributes.
Okay, I think you have to align precisely with what's in the soon to come RFC BCP op, because there are some things there that I don't see here, like the support URL or the jurisdiction. So I think
which working group? Sorry,
the best practice we're just going to publish on with. I mean, you refer to it in parts of the draft, but then there are certain things in the drop statement in the.
Yes, we have missed some, so we'll definitely include that. So yes, yes. You have to align. Thanks.
Hi, Eric Rescorla. So, I guess I'm having a little trouble understanding how this works in practice. So let me just try to work through the example. So I join a network. And I get some DHCP advertisement that says, here is the server. Are we assuming that's a DOH server for now, or a dot server, or are we assuming it's any kind of server?
Both could be.
But it's a secure server.
Yeah.
Okay. And so I connect to that server, and I connect over TLS, and I guess we assume it's got a web PKI cert, and I check the web PKI cert, and it's got some domain name. And then I fetch this object over that. Okay. And this object itself is signed. And I assume it's a little unclear in the draft, but that ADN is supposed to be bitwise identical to the domain name the domain name in the cert.
The authenticated domain name of the DOT server, or.
But this is supposed to be. I'm supposed to compare this to the thing I'm connecting to.
Yeah.
Okay. So that's what binds it. Okay. And then this is signed by some other web PKI cert.
It could be signed. It could be signed by you, your organization hosting the DOT DOH server, like using your OE certificates, or it could be also signed by an auditing company which has done an audit of the DNS server privacy policy.
Oh, okay. Fine. And then I'm supposed to examine those names and come to some conclusion about whether things are cool.
Yeah, one thing is DHCP can be pretty much easily spoofed today, so this would at least make sure that, for example, an internal attacker or an external attacker is not hosting a DOH server and then saying that he has a privacy policy, right?
I understand, but what I'm saying is I'm supposed to like examine those names because
this can be done by the client itself. I mean, the user
Sorry
is-
to break in the discussion. I think it's very useful, but given the time and going all the steps.
Okay. Well,
yeah.
then-
So
then
if you
instead-
can make
instead of
a
trying to
small
be-
summation, I think you have a point, but either can you?
Sure. Well, I was trying to lead us to that
maybe
point.
take
I was trying to lead us to that point, which is that the nature of the web PKI is mechanical comparisons between names that the user already has, which is to say domain names, and things that, and then things are in the certs. It is not examination of the names in the certs by humans to see if they're cool. And this system does not have that property. This is the property that I'm supposed to somehow examine the cert and like look at the organization name or look at, or God forbid, look at the domain name and be like, is like UA Airlines internet.com something I like? That is not going to work. And is the reason why browsers are increasingly abandoning the display of the certificates to the users. So like for the so like doubling down on Mark's point, like this is not going to work for security reasons because the interface is like unacceptable to like for any actual purpose. And EV will not solve that problem.
Alyssa Cooper, just coming back to the machine readable policies bit. So in addition to the example of P3P, this is actually a technique that has been tried in a multiplicity of different venues in different ways and has failed like basically every time. We even have an example from the IETF itself. We tried to do this for location privacy. It was a working group called GeoPriv. We specified the policies in a machine readable format and nobody was interested in using them in any way, shape, or form. So I think you would have to think about why this is different in some way from all those other examples, and it's not really obvious to me. I understand that that's fairly unsatisfactory given, I mean, if you believe what Ecker said, that like neither a machine readable way of negotiating this nor a way in which the human being is involved actually gets you very far. But I think that's just unfortunately kind of the state of privacy on the web.
Okay.
Thanks. Yeah, I don't know if folks had read it, but the chairs had read the draft, and we found a lot of hand waving through lots of sections, which is why we were trying to sort of keep the comments, because I figured most people making comments actually hadn't sat down and read the draft. So, and we want to get to actually the meat of the meeting, which is actually trying to get moving in our phase 2 problem sort of stuff. So we've got Alex and Jason are going to get up here in a minute. So I'm surprised you guys aren't ready.
Ooh, that's fancy.
Yeah, that's.
Okay, so I mean, the bad news or good news, I'm not sure yet, is that I have to leave about in 20 minutes. So
Oh my gosh. Oh, yeah.
I'm gonna leave the rest to you guys. And so what we did, as you know, Benno, Jason, and myself got together and we created that LMO, which is living at my over under DPRIVE phase 2 requirements -01 revision. We are developing that in Markdown form at that GitHub repository. So we did roll a revision for the interim meeting, and we did roll a revision for this meeting right on the day of the cutoff. So can I ask you who has actually read it? Yeah. Oh, well, pretty impressive, yeah. So we had an interim meeting where we discussed that document, and we identified during the creation of the version for this meeting that we have a couple of specific areas of feedback and working group discussion that we would need to address, and we've put them on the slides here. So the idea of that document, if I get it right, chairs, you disagree, is that we are not going to publish that. So it's going to stick around in the working group as a working group item eventually for a while, but it's not going to get an RFC number sticked on top of it. Yeah. So yeah. So I mean the basic structure of the document. We have a section that identifies like the threat model, Got it. And in a subsequent section, we have those perspective, as we called it, so for each of the different entities interested in like operating or using encryption between recursive and authoritative, we have different perspectives, and we have a lot of use cases in there. That's quite an extensive section. And in the subsequent section, we have the actual requirements. So the idea is that at some point, we can actually use the perspectives and use cases section to do a gap analysis with regards to the existing requirements that we have in the document. And when we have found out that we have like identified all the requirements that came out of the use cases and perspectives, then we can actually remove that section or move it to the appendix or whatever. Since we don't publish it anyway, I mean, yeah, we say RC editor here, but since we don't publish it, we can probably keep it as an appendix. But that is a lot of text that has all kind of sorts put into, so we can remove that to a later point. You want to add something to that, or? Okay, cool. So yes. Let's move right into the discussion, I guess. So the first important question to us, we're trying first, let me step back a little bit. We are trying to keep that as issues on GitHub. Right now we have all the open question as one issue. We might want to split that out at some point if there's more discussion about it. So the idea is that as soon as we have no open issues in the GitHub account anymore, we are done. Yeah. And that means that as soon as we close all of them successfully, not delete them. So the first thing that we have that's probably pretty important is anything missing from the actual threat model and problem statement. So we can discuss this here, and if you have input to that, we would appreciate it. If we're missing something important, Becker? Oh, no? You can also post it to the mailing list, of course, and we will.
I mean, I don't know if you're missing it. I mean, I read this threat model as required. So we had a long discussion on the list about the threat model, right? And in particular about whether it was intended to prevent, downgrades effectively, whether it was downgrades all the way through the system, right? And this seems to encode, I guess, my view, which is that the system should prevent downgrades and that you have referential integrity all the way. And so if you start from the top and you have dot to the top, then you should be able to get like. They should have referential integrity all the way. But I heard a lot of people saying we shouldn't necessarily do that. So I think that probably is a topic we should not just pass over in silence, but rather have discussion of.
Sure. Got a big section on that in a bit. We got another question in the subsequent slide about.
Oh, okay, fantastic.
Yeah.
Okay,
downgrades is like one of the harder things. Yeah.
Peter Spacek from the Jabber Room. Maybe we should explicitly state that attacker who has access to all traffic is out of scope. Again, in that case, traffic analysis will give out almost all the data, even without decrypting DNS traffic. Ecker says he doesn't agree with it at all. And since I'm at the mic, I'll say I also don't. But as Jabber Relay, that's what Peter said.
So I'm not up to date on the threat model. I haven't read it in a while, but one thing that was mentioned, I think by Christian Wittema, that I think is valuable is we should think carefully about any interaction here with CAA, ACME, and domain validated certificates. That is, if there is any dependency here on the web PKI, we have to make sure that we haven't created a circular dependency that is actually a vulnerability.
Yeah, that's coming up as well. So, any more on the general threat model? Because otherwise, please post to the list. We're gonna watch the list, of course, and we're gonna roll things that we discover on the list into issues into the GitHub. So, the next issue that we discussed internally was do we actually imply that DOT is always used between recursors and authoritative servers, or are there situations where some other type of privacy enhancing mechanism, privacy protective mechanism, QNAP minimization, whatever, is good enough? So it's a different story whether we require DOT. So the first requirement is use DOT all of the time, yeah, or not. Yeah, that's an important issue, I guess.
Ben Schwartz, I don't understand the question you're asking, but we never have the ability to tell people, we're not the protocol police. We can't force people to do
anything. So we can define this protocol, but we can't make people implement it. So what does it mean for the protocol to be defined but not always required? I don't understand.
Let me put it that way. If there's another privacy enhancing, privacy protecting mechanism available, is that an option as well? So should we create your requirements in the form that they are not specific to DOT?
So I think that we should focus.
Just to chime in, I think we noticed that there were some people on the list that suggested that DOT would be appropriate, say, from a single level domain between a recursive server and a single level domain, but maybe up to the root. Like maybe some of them or some TLDs didn't want to do dot in some scenarios, and there would be other mechanisms that you could use. So you could conceive that the protocol might have different sort of selection criteria for which hop of recursion you were doing. That's all we're really asking, because we couldn't discern from the mailing list where the consensus was, and that's what we're trying to get a sense of.
Sure. I think that so I think we should be in the business of defining this protocol and describing the properties that it has, and we can certainly compare it to other protocols and the properties that they have. Maybe there are cases where there's equally good alternatives.
So short answer is yes, dot is always required, right?
No, I'm saying dot is always required if you're doing dot, and whether you're doing dot is not something that we can tell you.
Okay.
Yeah, I think that was interesting. Eric Scroll, I think I sort of agree, Ben. I think maybe like a different way of putting it. So let's like hypothesize that there is some way in unspecified now, but to discover that a delegation ought to, the next NS ought to be like supports secure transport, right? I think you'd want to say what you say would be, here's like how you indicate that like this NS reference supports secure transport, and this is how it tells you what kind of secure transport it supports, and this is what you want to do when you get that if you're like a compliant dude and a compliant resolver, and and then separately I suppose we could say we encourage a la host requirements, we encourage resolvers to do this kind of thing, right? But I guess I agree with Ben that like that's kind of like the limits of our thing. I guess it seems like you might want to have an equivalence class of what secure transports means. So I guess I don't want to get into DO versus DOT, but certainly someday we may imagine that may do DNS over quick or DNS over DTLS, I suppose. And I think you can imagine having a variety of secure transports you think have are an equivalence class. I think QMIN is not in that equivalence class. But I think so. You certainly wouldn't want to be like dot forever, like you can't do DNS over quick, but I do think like we should like try to think about, we're trying to encourage people to do secure transport.
Okay, so what we are saying is essentially we should probably rephrase and say secure transport instead of DOT.
Yeah, but I think again, I don't think always requires a way to think about it. I think the way to indicate is there's a way to learn that people do it, and then you want to do it.
Wes Herdeker, ISI, pulling it up and relabeling sort of what Ecker just said. When I read through the document, I loved large portions of it. I like the fact that you broke down, that there's different levels of the DNS name, and things above the PSL is, possibly need to be dealt with in a different way, especially when talking to the root. If you're doing community minimization, I think all of that was fantastic. The problem is that a lot of the text is not talking about requirements, but rather solutions. And I know it's been mentioned on the list, but functionally, even this little statement is really saying, is this solution always required? Right? So you're pre-picking the solution rather than saying, is encryption always required? And what are the requirements, if encryption is required, what are the requirements of bootstrapping that? How do we get the trust anchor list and things like that? So if you just reword a lot of and it's not just a section, it's sprinkled throughout, and I would divide that up into requirements and then maybe solutions if you want to include it, bootstrapping a conversation.
Yeah, I find it's a pretty common problem in the IETF that we all engineers and we tend to think in solutions immediately.
Yeah, I feel like, really the requirement is we need to be able to securely, and that means encrypted, to get from the bootstrapping down to the name we have to do. And be .doc or whatever, we don't care. It has to be a secure mechanism that we define.
Okay, thanks.
Brian Dixon, GoDaddy. I think breaking out a couple of different distinct aspects of this would be possibly more helpful to achieving the goal of getting consensus on requirements. One of which is the delegation chain, if it's signed versus if it's not, and whether in order to achieve privacy, and if you are using DANE, then you need to have a secure delegation all the way down to the domain name server that you're going to connect to over an encrypted transport. The other thing would be potentially looking at what the mandatory to implement is, and whether, depending on that, that may actually turn into requirements for what the client supports as opposed to what the server has to support.
Okay, thank you.
So it sounds like to change it to more being focused on encryption rather than, secure transport.
Secure transport is the keyword, Perfect, thanks. It's very helpful. Trust anchor security. Should the secure transport, depend only on the DNS, such as DANE, or should we also do some kind of like PKI stuff besides the DNS mechanism?
I plead with you not to get into this. I really do. If we could get to the point where, like, if we get to the point where, like, we're like, this was the open question, we'd be in such a better position.
So should we be silent in the document about this? This is like not going to the dentist,
So Ben Schwartz, maybe to rephrase, I think that this is not the right level of requirements.
Okay.
That this is getting very close to the solution space.
So maybe rephrased again, thinking of the secure transport rephrasing a moment ago, maybe this is about being able to validate in some way with an independent authority, that bootstrapping is valid or something like that, like, something much more generalized.
So I don't agree with that characterization of the previous comment. I think that what's needed there, you mentioned alternatives. I think what's needed there is not a recommendation to use or not use encrypted transports, but a comparison of the properties of an encrypted transport versus QNAME minimization in different scenarios. So I don't think that that's a requirement that we need to think about now. It's just something that we need in the explanatory text at some point in the document to help explain people what they're buying if they're implementing DOT and what their other options might be. On this topic, I do think it could be useful to enumerate a few different cases here, but I don't think that we can determine now which ones we'll be able to solve. I think that we're going to have to explore the solution space to figure out what's tractable and what's not.
Right. Yes. Okay.
Ben and I agree on this point. I think. I guess taking a step back, right? There are two effective settings, right? Three. One setting is one where you have out-of-band information about the resolver you're connecting to, which is, of course, the situation with, like, these the dot and do client to recursive situations where, like, you're given a domain name and you just connect to the thing. The second setting is one where during the resolution chain you learn here, go somewhere here, and you're supposed to connect to that person now, and somewhere in there there's got to be if that's going to be secure against active attack, there has to be enough information that when you talk to that next guy, you're able to determine that the reference you were given corresponds to the thing that you're connecting to. And there's like a pile of ways to do that. I think some of them are more tractable than others, but we don't have to define that here. That the key point is a referential integrity, and then finally there are these there's the opportunistic discovery where people are like, hey, I'm going to happy eyeballs and see if this guy supports dot or just like go 53. And like in that case, there's like no point in authenticating the person at their end because like it is what it is. So I think those are the three cases. It's really the case that is important that needs like some definition is if we choose to build something that has referential integrity all the way down, that it has to have referential integrity at that stage. The reference has to be correspondable to the credentials that are given to you by the person you're connecting over secure transport.
Thank you, Hacker.
Christian Wittemer. It it's not directly related to using what you use to secure the whatever secure connection you have between the client and the authoritative. But I am scared about the circular dependencies between PKI, ACME, and DNS security. So it's easy to envisage a case in which you can only get a certificate for some name if you can prove that you control the resolver for that name. But then you can only get to the resolver for that name if you already have a way to assess that you are the right resolver with a certificate for that name. So this notion of circular dependencies should be put in the requirements, as in, this is the thing we shall not break.
Should we add to the requirements that any implementation or any solution should be careful about such loop dependencies?
Yeah, you should basically list the potential dependencies and says whatever you do, don't break that.
Yep. I absolutely agree. Yeah.
That was just brought up in the last one too.
Yeah.
Brian Dixon, GoDaddy. So I think one of the things that might need to be called out is the fact that this is what's agreed on between the resolver and an authoritative server. The authoritative servers are, depending on how we define these documents and requirements, free to use, if they're doing DANE, 4 different models, which can include non-CA signed certificates that can either be self-signed or signed by some non-CA parent cert, which can be protected through the DANE delegation and the DANE validation, which means that giving the list of what the methods are and what the security properties are, if you do or do not support these validation mechanisms, is, I think, critical to the implementers to understand, especially if large authority servers effectively commit to not doing anything other than DANE, because that becomes a critical aspect of it working, as well as what the take up is on the resolver side.
Daniel Kahn-Gilmore. So my head is spinning at the thought that we care, 1, about avoiding circular dependencies, and 2, that we might want to do some sort of hybridized DANE plus WebPKI plus third-party, perhaps any of the above certification models. So I think that sounds super complicated, and the idea that we're going to get that right, that all of the players in the game are going to get that right, is really scary to me. So in some sense, I find myself, and I know we're not supposed to be talking about solutions here, but I actually think that we should put in the requirements that something that we're going to have is going to be simple enough to be analyzable, which I'm not convinced by some of the proposals that I've heard. Secondly, I wanted to generally agree with Ecker's breakdown, the sort of 3-part model, right? Preordained knowledge, hierarchical delegation, and happy eyeballs, as sort of the paths you get to these sorts of privacy things. But I wanted to, having just said we shouldn't complicate things. I think that so a lot of this stuff has to do with, there's a temporal dependency in these things as well, right? A delegation that you get is time limited by a number of different things. The certificates, if we're doing WebPKI, have limits. The DNS records have TTLs. There's all these other time limitations. And I wonder if the happy eyeballs opportunistic mechanism might also opportunistically provide you with something that's more verifiable than you would have gotten from the strict delegation. And I wonder how that interacts with, like, what are the temporal aspects of that? So for example, rather than getting an explicit delegation, I might get a happy eyeballs approach where, hey, whoa, we've got dot. And somehow by having gotten dot in that case, I learned something that I can retain so that my next query, at least for some temporal duration, will ratchet that in. So I just want to sort of flag that as an additional wrinkle to Ecker's 3-part breakdown.
Okay.
One quick second. And we're just going to stay away from WebPKI completely because we think that's just a here, that's just a place fraught with just disaster.
Yep.
Well, I guess that was not what I was saying. What I was saying was do not discuss Dame versus WebPKI at this moment. I was not saying say don't do WebPKI. I think I see different people in the room with different opinions about whether or not it's going to be viable to have these be WebPKI search or Dane search, and I just don't think at this point in the game, like setting requirements, that's a sensible thing to engage with. I think later maybe we'll have to engage with it. So I think DKG, you just thumbs up. You're thinking basically something like HSTS, right? Where like I connect to the server and it goes like, I promise I will be dot for the next 2 weeks, right? Okay. Yeah, I think that's an extremely valuable kind of idea. I think we would not want to do something like HPKP where it's like I promise that that I will have this key for the next 2 weeks. That didn't work out so well. So, you think so? You think we should?
Yeah.
And we're like taking that out now,
I'm afraid, guys, that I have to leave anyway. So I leave the really hard ones to Jason and Benno.
Yeah, and I suspect we're going to.
I think the line between HSTS and HPKP is fuzzier than we think it is, and there are other implications around the choices there. So yes, I agree that giving people horrible foot guns is a bad idea, but I'm not sure what the actual line is in this particular context. Okay.
All right, so we need to move on. Can you?
Sorry, I do want to respond very quickly. One of the things about any of those other pin-up things is it does not honor things that are in the DNS itself. If there is a Dane thing with a TTL, that absolutely has to be honored. Otherwise, it breaks the security model.
Okay, so there was a lot of discussion on the list about what choice we should make here. And there seem to be a few perspectives expressed, and we're trying to understand how to put these into requirements or how they translate or apply. So the question is really, should the user, whether that's the stub resolver, the application like a browser, or the recursive resolver, be able to say for a particular upstream server, only ever use secure transport and never downgrade? Or should it, or maybe in some cases, that is permissible, or should the authoritative domain, whether the owner or operator, should specify that, say in a some sort of DNS record, or should we be silent on this and not worry about it for requirements, and either side could decide.
So I guess it seems like you're offering three options. One is that the client says don't only ever use dot.
Yep.
Right.
Server or
I don't see how that works, because then the day you turn that on, you don't want to talk to anybody. So that seems like we're pretty. we're not even there. We're not. We're at 90+% HTTPS penetration. We're terrified to turn this on for HTTPS. So I think that's pretty far out of the future. I think that similarly for backward compatibility reasons, the authoritative domain obviously has to advertise a way to talk to the next guy in the chain, not via dot, because otherwise people who only speak dot will everybody who currently in existence will just choke, right? So so I think the only things you can plausibly say are here is how to talk to me via dot, and here is how to talk to me via not dot, and then we can talk about the semantics of how you're supposed to do, what you're supposed to behave when you consume that information. My instinct obviously would be to have to say that if you're given both of those and you're a modern person, then you want to take dot and you want to refuse to connect to the other one. But just because of the temporality, was not much else you can say. I think that the two semantics you can plausibly have at this point to be advertised are, number one, I speak dot and you really ought to use it, and I promise to have it on indefinitely. So if it doesn't work, that's an attack. Yep. Or conversely, I speak dot, but I don't really promise it might not work, and maybe, and then you have better happy eyeballs. Those are the only sensible things you can plausibly say. I think the second one is not super valuable, but I can understand it. I think it wouldn't be a tragedy to have both settings, both indicators. But like I say, you have to be able to advertise both, otherwise people will start breaking.
Okay, good. And I like the two scenarios that you gave. I think that's great for requirements. Thanks.
Ben Schwartz. I don't think it makes sense for the stub resolver to provide any instruction about this to the recursive. I would be strongly in favor of removing any of that from the requirements, and instead saying, for example, that there be no change required or involved at all in the construction of queries formed by the stub. In particular, we're talking about something here that is completely unverifiable from the stub's perspective. Stub has no way to prove whether this happened at all, in contrast to, for example, the DNSSEC OK bit, where at least if things are working right, you'll get an RR sig back that tells you that you can use to verify locally that the recursive did what you wanted it to do. Also, I think that the bit we're talking about here gets extremely strange very quickly. For example, it's not clear what, if you imagine that the stub is allowed to say only do DOT, then you have to try to understand what that means about reading results out of the recursive cache. You have to think about what that means about whether the root has implemented DOT or not, or whether a local copy of the root that was fetched over an insecure transport but DNSSEC validated is considered appropriate. I think it's a gigantic can of worms and we should exclude it.
Cool, thanks.
Feedback on with my sort of resolver vendor on it. No, I mean, really, resolving is already complicated enough. We have to shard the cache for ECS. There's QNAP minimization. There's NX domain. I mean, there's lots of stuff that's going on there, and it's really complicated. If the client wants to have an assertion, he should do the things himself. Maybe the way that the app of the DNS was prepared. But the resolve really should do its stuff. And I mean, if any client would have to say turn it on now, that reminds me a bit of the early versions of the Microsoft DNS server, where if you turned on DNSSEC on the domain, everything underneath has to be validated. So it doesn't work at the moment, and it's really complicated. So I mean, we should not have it as a requirement.
Okay, so I'm hearing lots of plus ones. Don't do the client side stuff. So.
Yeah, one more plus one from DKG here. So this reminds me a lot of the required TLS mechanism in SMTP, which is very difficult to figure out how to deploy it, even in a situation where we had Start TLS available for a long time. Yeah. I want to call out the similarities between this project and Start TLS for the SMTP network. I think we did a great job at getting Start TLS out there into SMTP, and we didn't do a good job of figuring out how to ratchet ourselves into a majority Start TLS world until another decade after that. So I appreciate the attempt to think about how we get there, but we're not even at the stage of Start TLS is deployed in this mechanism. And I think we need to get there first. It's just the curse of the deployed base, right? That's what we do here at the IETF.
Yep.
Wes Hardiker, ISI, I'm going to both agree and disagree with DKG, I think. RC 7672, I strongly suggest going back to look at. So that is Dane and SMTP and how those work together. And Victor Duchovny put a lot of effort into how to deal with the situation. Yeah, there's always a train of trolley carts behind all of these rooms. It makes for an interesting week. So he thought long and hard about how to deal with situations where the user is removed from the decision-making process of starting up TLS. And so that 7672 is actually defined as an opportunistic encryption role too, where you do the best that you can under the guise with the information that you have. And you may end up starting TLS even when you don't necessarily know the other side, if you can't, find the right Dane record to get you all the way there. But the important part is not actually the semantics of actually how to make that connection, but rather the fallback logic of, he put in a lot of very good description of what's the best you can hope for, and here's why, and here's the logic to walk through.
Brian Dixon, GoDaddy, +1 to what Wes just said, +1 to not the client. I think from the authority side, there may be some value to guidance from the authority on how to deal with the happy eyeballs requirement or just intent, such as using some version of serve stale if the DOT isn't reachable, rather than trying to go over DO53 versus the information effectively not having a lot of privacy value and just allow it to fall back without trying to do serve stale.
Pat McManus with Fastly. Just to sort of riff on DKG, saying maybe the requirement should be that we deal with discovery and advertisement of non-downgradable services, right? So the way HTTP solves this is with a URI scheme. I mean, HTTPS does that, right? In a way maybe SMTP didn't, so that might be the requirement to focus on.
All right, great. All right, so now we're to requirements on discovery. So what requirements do we have for a recursive to determine availability of, dot in this case, on an authoritative server? So I think, mostly this is via whitelist today. So are there any requirements that we want to place on this? Like it has to be in the DNS, or it should be, completely automatable independently from different entities? Any requirements that we haven't thought of or that have come up on the mailing list that you'd like to be certain are included here?
Brian Dixon, GoDaddy. At least my opinion, it has to be in the DNS, should be DNSX signed. And it should be associated with the name of the name server rather than the domain being served. I think it scales much better that way, and it provides all the necessary parts as far as delegation signatures.
Wes Hardiker again. To put it another way, we have a distributed hierarchical lookup model. Why would we look somewhere else for information on how to use it?
Eric Scorla, yeah, I mean, I think this ties in directly to what Patrick McGinnis just said a few minutes ago, that like there's needs to be some way semantically to say this thing ought to be encrypted. The rest of it seems like no.
Okay. All right, so we've gotten a lot of notes here. We'll compare as co-authors and look at the notes, of course, from the session and the Jabber room. And make those changes and, I guess update it. It'll probably take, quite honestly, a couple weeks after the meeting to get back and catch up on other work and then do an update.
Yep.
So certainly before end of year, I think we'll have a next revision. And then the question is like, do we just, keep this document and keep it on?
Yeah, I think what
I think working group
when
doc?
Brian and I talked about was just adopting it, having you guys, like, you'll do some updates and we'll just adopt it as a working group only document. We won't have to go through a lot of that sort of process stuff.
Exactly. Yeah.
And then then the group can just start chewing on it that way. Good. And making all their suggestions and stuff.
Yeah, and I think one note that we said at the beginning, just to be clear, so we will be looking in particular at the perspectives and use cases. There are a bunch of requirements there that we probably missed that we'll have to pull in, so we'll do a quick gap analysis. The rest of that we'll just put into appendix. It could be deletable later just to make this as simple as possible in the main body. Yep, right.
Sorry, Brian Dixon, GoDaddy. I think just from a very high level, from building the requirements, I think definitely making the distinction between things that are for providing the service on the authority side, what the value propositions are and what things should be recommended versus what things should be mandatory to implement, versus in order to achieve the privacy on the client side, if you want to get the privacy, you may need to implement certain things, but it doesn't need to be mandatory because it's always the choice of the resolver.
Yeah, that's a good point. And I think that's probably one of the next discussions to have once the doc is updated is, which of these are firmly mandatory and which are potentially optional ones.
Stephen Farrell, so I think this might be more a question for the chairs than you, but so at what point are you encouraging people to sort of actually write into that draft saying, here's how I would do the signaling, here's how I would use a funny name for an NS, or because I think I've seen a bunch of discussions on the list where people kind of put in little snippets of these ideas in mail and it gets confusing. And so I'm just wondering, at what point would you like to see more formulated?
I think fairly soon. I think once we sort of do an update on this and sort of get it a little structured, Brian and I actually already meeting scheduled on Tuesday to sort of go through some of this, but I figure, once that happens, I would say then we can start, people can start submitting stuff on here's how we think about solving it this way, or here's how we can look at it this way kind of thing.
Great. Yeah. So I think it might be helpful if you and Brian to send a mail to saying, okay, ready, steady, go.
Yes, exactly. And I think what we're going to wait for is to go through have the authors go through and do an update, and then we can push that out. And because of the holidays and stuff, I'm not expecting that till the end of December, basically.
Yeah, and I would say, the mandatory versus, optional requirements, I don't think bears too much on people doing proposed solutions. So I think once the next rev happens,
yes,
those things can happen in parallel.
Exactly.
Brian Dixon, GoDaddy, one other comment, just in case, just a reminder, if anybody's interested in testing an actual implementation, which is way premature, but we actually have in our OTE environment, ADOT set up.
Also, one thing that came up before Paul speaks is Brian and I, if we do get a lot of good feedback, if people start submitting drafts like Steven says, we are totally open to having another intern before Vancouver to sort of chew through some of this in a very focused way. So just keep that on.
I just got a question about clarity. I don't actually care much what the answer is, but I was confused by the intro. Is this an internal working group document or something we're trying to publish with IETF consensus?
Internal.
Okay.
Yeah, it'd be adopted working group only. Just
right,
for us
but we don't intend to publish it with IETF
no,
consensus.
Exactly.
Well, maybe not. I don't know. It can go in some other reference pointer. I mean, it might be good historically to point back to. Doesn't matter.
I think it might matter, so we should probably want to be clear about where
what do
we
you
want it
think
to
then?
go. I would write it a little bit differently if I was trying to get cross-area review for it, right?
Okay. All right. Thanks.
So wait, actually, this is Paul Hoffman, and I haven't gotten to the mic because I've been trying to take notes. A major thing that is not covered in this document is zones whose name servers are not all controlled by one organization. So there's two issues here that, again, is not covered at all, and I believe that we do have requirements about it from the DNS. One is, are all NS records considered equal? And a very simple case would be a zone that has two NS records, one that offers dot and one that does not.
Right.
So that's one thing. But the other is for organization or for zones where there are many name servers that are known to be run by wildly different organizations.
Mm-hmm.
How do we, how do we want to handle that? And I'll just say it as one word: the root.
Got it. So in that scenario, it's like, you're the domain owner, you're using, 4 different CDNs for a particular zone and so on. Yeah. Okay.
Yeah, that actually seems like a case for client policy. But I just wanted to, in reference to Patrick's question about the fate of this document, I'd call your attention to the November 2016 ISG statement on supporting documents for working groups, which strongly suggests that documents like this do not end up being RFCs.
Whatever. Okay.
That's right, and that's what
Whatever.
Yeah.
Brian Dixon, one comment about the question about name server names in the NS set. I would recommend putting in recommendation that those be retrieved from the apex of the zone rather than the delegation glue.
Awesome. Yep. So that's all you got. You've got some work cut out for you.
Yep.
We have some. I know the chairs have some work cut out for us in the short term as well. So, so if there's not anything else, if hopefully everybody signed the blue sheets, we're doing pretty good actually. So surprisingly, considering how late everything sort of ran. As I said, Brian and I will talk next week. We will probably actually a couple of these documents that we talked about earlier. We want to go back with the other chairs on the other groups and sort of discuss how they sort of fit in, if they do or not. Focusing on our sort of tight charter, it expanded a little bit with the phase 2 work, but it's still sort of focused on what's going on. And so we'll sort of see where that goes. So thanks everybody. I appreciate all this. Like I said, if it looks like we get a lot of good stuff going on with the phase 2 requirement, especially with solution stuff, we'll probably plan on doing an interim in February before the March meeting. So chairs will take that up and sort of see what we can do with that. All right. Thanks all. So where are the blue sheets? Oh, cool. Thank you, Daniel.